Okay, so in this lesson we talked about ionic bonding, and what we're really trying to do today is focus on how to name a compound or how to look at a name and write a formula for a compound. So to review really quick, atoms gain and lose electrons to become stable. They form ions. An ionic compound is a compound formed when atoms lose electrons to other atoms that gain electrons. The positive ion is then attracted to the negative ion. So when we talked about ions, we talked about these atoms losing electrons. Where are they losing these electrons to? They're not losing them to nowhere. They're just losing them to other atoms that want to gain them. And our big idea for today is that electrons gained must equal electrons lost. And we're going to try and always conserve these electrons, making sure these numbers match. Now there's three types of ionic compounds. I'm going to break them into just for the explanation purposes. We have simple ones that include main group metals and nonmetals. For a simple ionic compound, now going up here, we want to make sure the charges are always balanced. So for instance, sodium likes to form a +1, chlorine likes to form a -1. The one sodium atom will lose one electron to the chlorine atom. It's a 1-to-1 ratio. And then in naming this, we're just going to state the metal, sodium, and then state the nonmetal but end in the suffix "ide", so sodium chloride. Now for Na and O, since sodium is a +1 and oxygen is a -2, it would take two sodium atoms, each losing one electron, to balance out the electrons gained by the one oxygen. So the formula would be Na2O. And then again, we're not going to use these numbers in the name. We're just going to state the metal, sodium, and then state the nonmetal but end in "ide", so sodium oxide. And then this last example, barium likes to lose 2 electrons, form a +2 charge. Nitrogen likes to gain 3 electrons each to form a -3 charge. That means it would take 3 bariums and 2 nitrogens to have the total electrons lost equal the total electrons gained. So we're going to get this 3-to-2 ratio. Again, barium, just state the metal. Nitride, state the nonmetal but end in "ide". Okay, now the second type of naming technique is going to include the transition metals. So here's the idea. Transition metals can lose different numbers of electrons. If that happens, we need to make sure the name includes the Roman numeral to tell us how many electrons are being lost by each atom. Okay, in this example over here, what if we had FeO as the formula? I like to go this roundabout method here. So oxygen, we know the oxygen is going to gain 2 electrons, so each oxygen atom will be a -2. Since there's one of them in the formula, we're going to go 1 times -2 equals -2. The opposite of -2 is +2, and then +2 divided by 1 is +2. So the name of this compound will be iron 2 oxide. Okay, another compound that exists on Earth, Fe2O3, is going to have a different name. So we still start with the charge of the nonmetal, -2 for oxygen. 3 of them in the compound, so 3 times -2 equals -6. The opposite of -6 is +6, and then +6 divided by 2 is a +3. So each iron atom is losing 3 electrons to the 3 oxygen atoms. So we would call this compound iron 3 oxide. Notice we're not naming it using the number of atoms, we're naming it to identify the charge. Okay, let's go through some practice problems now. So for this first set of problems, predict the ionic formula that forms. So I think for when I'm guessing the formulas, I always write the charge above the atom there. So sodium likes to form a +1, chlorine likes to form a -1. Do those values equal? Yes. So the simplest way to write this would be NaCl. 1 sodium atom losing 1 electron to 1 chlorine atom gaining 1 electron. So in the second example, magnesium likes to form +2 ions and lose 2 electrons to become stable. Oxygen likes to gain 2 electrons to form -2 ions to become stable. Are these numbers the same? Yes. If so, MgO is the simplest way to write this formula. Notice we're never going to write Mg2O2. We always want the simplest formula possible. Now this third example, sodium is a +1, oxygen is a -2. These numbers are not the same. So now we need to make sure we have 2 of the plus ones to equal to 1 negative 2. So our formula would be Na2O. Okay, down below, identify the charge of the transition metal in the following compounds. Now, when you're trying to find the charge of the transition metal, I want you to always start with what it's with. So in this first example, the copper atom or the copper ion is with a chlorine ion here. Chlorine is a -1. There's one of them in the compound. 1 times -1 is -1. The opposite of -1 is +1. And there's 1 copper in this compound, so 1 divided by 1 is +1. So this copper has a +1 charge. Now in the second example, chlorine is still a -1, but since there's 2 of them here, 2 times -1 would be -2. 2 electrons are being gained total. That means 2 electrons must be lost total, so the opposite of -2 is +2. And since there's still 1 copper ion in this compound, I would say +2 divided by 1 is +2. So this copper ion has a charge of +2. Now in example C, I'm noticing I have something more than 1 atom here, so this must be a polyatomic ion. I would look up on your periodic table, go ahead and find CO3. It looks like CO3 has a -2 charge. Since there's no parentheses here, that means we only have 1 carbonate ion in this compound. So I would say the total negative charge is -2. The opposite of -2 is +2. 2 divided by 1 is +2. So this cobalt atom is a +2 charge. Now on the right here, SO4, again, it's not 1 atom, so let's look on our periodic table. And SO4 is the sulfate ion, and it's a -2 charge. Okay, this time we do have a parenthesis indicating that there are 3 sulfate ions in this compound. 3 times -2 is -6. The opposite of -6 is +6. We're going to make sure the electrons gained equals the electrons lost. And then 6 divided by 2 ions in the compound would be +3 each. So I always go this little roundabout method of determining the charge of the transition metal. Okay, let's finish this practice off by naming the following compounds. Mg3P2. This is a main group metal with a main group nonmetal, so we're just going to name it with the name of the metal, magnesium, and the name of the nonmetal but ending in the suffix "ide", phosphide. Next, Mg3PO4. We have a main group metal, and it looks like this is more than 1 atom, so it's a polyatomic. So let's just look on our periodic table. And PO4 is right here. It is called phosphate. Many of these are not going to end in "ide", but the suffix "ate" or "ite". So let's just name our metal, magnesium. And then just name the polyatomic ion, phosphate. Okay, down here. Now notice that this one has our transition metal in it. That means we need to indicate a Roman numeral. So I'm going to start by calling it copper, parentheses, chloride. So what I've done here is I've told myself that I'm going to name it copper, I'm going to name it chloride, and then I know that I need something in here. So if you're looking at a multiple choice test, I'm just using process of elimination here. We're not going to use any prefixes here. That'd be for covalent bonding. And we know that we do need a parenthesis. So if you see something just copper chloride, you know that's not a good choice either. So what we're doing is we're narrowing it down to some good options. Okay, now what we practiced earlier was chlorines -1 each. There's 1 of them in the compound. 1 times -1 is -1. The opposite of -1 is +1. And since there's 1 copper ion in this compound, 1 divided by 1 is +1. So this would be copper 1 chloride. Now example D, chlorine -1. There's 2 of them, so 2 times -1 is -2. The opposite of -2 is +2. 2 divided by 1 is +2. So this would be copper 2 chloride. This last example, it looks like we have a transition metal, so I'm going to go ahead and write iron. It looks like we have a polyatomic, so we look on our chart. Where is it? CO3 carbonate. So we're going to call it iron